Hello and welcome to the lecture Introduction to Structures in C Programming. This topic is divided into several parts and we are starting with its initial part, that is part 1. The topics to be covered in today's lecture are Introduction, that means fundamental about structures, then what are the basic criteria to define a structure, some important rules in defining a structure, creating structure variables, creating structures, assigning values to individual structure variables, what are the different ways to do it, what are the various ways to initialize a structure, and if there are more than one methods, how they can be handled in C. So in a background introduction kind of thing, array are used for storage of homogeneous data. We all know that array stores a similar data type data elements, that is homogeneous data type. If it has to be maintained in a way where more than one type of data elements to be stored, then structures will be helpful in that way. Also, we have user defined data types like structures, union, enumerations to data store of different types. Array structures both contain a finite number of elements. That means we know how many such elements to be stored in that particular data type. Thus, array types and structure types are collectively known as aggregate types. On the other way, unions are similar to structures in all aspects except the manner in which their constituent elements are stored. In structure, separate memory is allocated to each element, while in union, all the elements shared in the same array, same memory. This memory kind of allocation will be discussed in part 2, and how it has been handled in union, it will be in part 3. Enumeration help you to defining data type whose objects can take limited set of values. And bit fields are a special type of structure or union elements that follow easy access to individual bits. These enumeration and bit fields will be handled in the last part of the topic. Now come to structures. A structure is a collection of variables under a single name and provides a convenient way of grouping several pieces of related information all together. That means we want to store heterogeneous data kind of data values, but they all has to be addressed with a one common name. It can be used for storage of heterogeneous data. There are three important tasks during working with structures. First one is define a structure type, that means creating its new type, defining variables and constants, which are also called objects of the newly created type, using and performing operations on objects of the structure type. This is a detailed syntax of a structure, which is called a general form of our structure. Struct, then structure tag name, its data type member list, again data type member list, and all such data types member list are enclosed within curly braces, and after then they has been terminated with the help of semicolon. If you observe that some of the square bracket elements are mentioned also over here, the description of such is given in this note section. The terms enclosed within square brackets are optional and might not to be present in the structure definition statement, but the bold term is a mandatory part. Every structure should be terminated by semicolon. You can see that once this curly braces has been closed, the overall termination is done with the help of this semicolon. Now, few important points during working with structures. These are utmost necessary points. Please go through it in detail. A structure definition consists of keywords, which is a struct, followed by an optional identifier name, which is termed as tag name, and the structure declaration list enclosed within the braces. So you have seen a syntax in previous slide. Here a description how it has to be declared, and there are two methods to define it. First one is struct. This is a keyword followed by a name which is called a tag name. In this example, my tag name is book. All the dissimilar data types elements of this structure are being enclosed within this curly braces. First one is character, title. Title may be of 25 spaces, 25 characters. Character, author of size 20, integer, number of pages, float, what is the price of it. All these are called member of my structure. This is the tag name and these are the members. The another way to declare such structure is struct only. See, no tag name is present over here. Only the description of it. Character, title 25, character, author 20, integer, number of pages, float, price, and finally I am terminating my structure with the help of semicolon. In upcoming slides, you will have a better description of all these different arrangements, when they are being used and how they are being handled in a structure. Important points about structure definition continues over here. Few more are there. The structure definition defines a new type known as structure type. Tag name of a structure is an identifier. We call it a variable also, or object. A newly created type is visible after its definition only in the scope in which it is defined. That means where we are defining a structure, it will be visible only in that particular block of code, not beyond it. Hence, it is not possible to declare objects of the defined structure outside the scope of its visibility. The structure declaration list consists of declaration of one or more variables, possibly of different types. A variable names declared in a structure declaration list is known as structure member fields. Structure members, or say fields. Have a look to this example. This will sum up all the points covered in the earlier slides. Let I have a function. Its name is function. There is a main. Main is having a description of one structure named coordinates. So I have mentioned as chord. Struct chord having two such elements, members, which are x and y, and I am closing it. Now create two such variables of this structure, struct chord point1 and point2. These point1 and point2 of the created type struct coordinate. Now see, if my main ends over here and there is another function which is named by function defined later, and it wants to initialize one more coordinate, say point 3. See, point 1 and point 2 are already mentioned in this main, and this structure is also defined in main. Outside this main, I am trying to create one more reference of it, one more variable of it. Okay, this is not possible. Other statement of the function, now I am closing it, and once I compile it, it will show an error. Compilation error. What kind of compilation error? The visibility of this coordinate pointer 3 is outside the scope of the life of my coordinate structure. Okay, some valid rules. A structure can become a member in another structure declaration. What it means? Say, I have a structure whose name is name. It is having two such members, first name and last name. Now I want to create one such structure whose name is this. Structure name having two such members, first name and last name. I am trying to terminate it over here. Now I want to create one more structure whose name is phone book entry, and this is having two another members, name and mobile number, and this name is the member which has been defined earlier, structure defined earlier. So structure phone book entry, I am creating one member person name whose type is of this structure name, and one character mobile number 10. In this way I can call or create a member inside a structure which is actually a structure itself. A few more points. A structure can contain pointer to itself. This is very important point, and in data structure it is widely used. This is also called self-referential data structure. A node in a linked list, example, a node in a linked list consists of integer data and pointer to a node. Say I am having data and pointer. It is pointing to some another data and its pointer, and in this way this is being followed further. Say struct node, for this linked list I am creating a structure named tag name is node having two such members, integer data and struct node pointer to node. So I am creating one data and one more pointer to node, pointer to similar type of data structure whose name is node. Now next, since structure definition does not reserve any memory space for the structure members, it is not possible to initialize the structure member during the structure definition. Means once I am mentioning this structure inside some memory block, then it is only be stored in terms of some template. And if it is template, it cannot hold some values to it. That is why we are saying that it is not possible to initialize the structure members during the structure definition. Means once it has been defined over here, character title of 30, character author of 20, integer number of pages, float price, this 30 or title cannot have some value, say my experience with truth, author as Mohandas Karamchand Gandhi, number of pages 400 and price is something. All such values cannot be stored once it has been in a definition phase. So this is invalid set of description. If a structure definition does not contain a structure tag name, the created structure type is unnamed. Okay, there is a structure, I'm giving such I'm not giving any tag name, and then it is be used as unnamed. It is not possible to declare its object after it has been defined. That means if I want to define some variables to it or some objects to it, they has to be defined then and there only. See, structure without having any name. No name is over here. Character title, character author, number of pages in integer, price in float. So once I am defining such kind of a structure which is usually unnamed or no tag name is there, then it is my responsibility to create its object at the time of its creation. That means once I am giving a definition to it, object should be there only. Thus, objects are unnamed. Structure type should be declared only at the time of structure definition. This is a structure definition phase. Similarly, const struct no unnamed, title, author, prices, float. Similarly, I am creating its object as book, and values can be assigned over here in such way. We will discuss how these values are being given over here in upcoming slides. This is called creation of qualified constant. Means I am creating over here, I am creating an object of it, and over here I am creating object as well as putting values to it. That means initializing that particular object. Some more important rules. The storage class specifier except type def cannot be used in a structure type definition if the objects are not declared at the time of a structure definition. What it means? See, I have used a structure point, have two members point, x and y as coordinates. In main, I am creating its object struct point pt1. This will create an error as compilation error, storage class static not allowed here. If I am mentioning static as a storage class and keeping in mind that this structure is defined outside the main, it is not possible to do so. What I can mention over here, I can mention over here only type def. Include stdio.h type def struct point x and y, two members of it, and inside main I am creating a object of this structure point as pt1, and this is a valid one. Keep in mind also over here I have used type def, then struct keyword, and then point. And see, here is missing. What is missing? The name of my structure keyword. Struct point p1, struct point pt1. This struct is not given here, and this is a good opportunity given by C that if I am prefixing my struct with type def, we get liberty to skip this struct at the time of its member creation or object creation. So they can be called directly by its member tag name point and its member variable pt1. Now declaring structures objects. Variable and constants can be declared either at the time of structure definition or after the structure definition. A structure variable, or say its object declaration, consists of following points: the struct keyword for declaring a structure variable. Const qualifier can also be used for declaring a structure constant if it is required so. A tag name to defining a structure type, and a comma separated list of identifiers. Initialization of constant is must. And finally, I have to terminate it with the help of semicolon. Upon declaration a structure object, the amount of memory space allocated to it is equal to the sum of memory space required by all the members. Say I have two members, one is integer roll number and a second one is float marks. Then if it is of 4 bytes and it is again of 4 bytes, then the overall size of my structure will be 8 bytes. I am repeating it again. Upon declaration of structure object, the amount of memory space allocated to it is equal to the sum of memory space required by all its members. Now declaring structure object variables. Creating structure variable is based on 2 points along with the structure declaration, another after the structure declaration. This has to be studied. Declaring structure object variables means creating a structure variable object. The type 1 is along with the structure declaration, means when I am declaring my structure, at that very moment I am also mentioning the desired objects of it. Let's have an example of it. How it can be handled? Declare a structure and just after closing brace, means this is my structure having something defined over there, and just after placing semicolon I will give all my objects. If those are more than one, I will separate them with the help of comma and the whole list will be defined over here. So just after closing brace and semicolon, mention one or more variables using comma separation. So here is an example. Struct employee. This is having 3 such members: employee name, number, name of it, salary of it, and just after closing or terminating my structure with the help of semicolon, I am mentioning a name of my object in between closing brace and semicolon. This is one of the way. Again, struct employee, integer employee number, name and salary, and now see, more than one such members are required: employee 1, comma, employee 2, comma, employee 3, and finally I am placing semicolon over here. In this way I can define or create a object of a structure along with its structure declaration. Now the second type, after the structure declaration, means structure has been defined earlier and later on we want to declare some of its objects or some of its variables. To do so, declare a structure and terminate its declaration with semicolon as you do normally. Now define its variable or object just like you define any other variable, but keeping in mind that before the tag name keyword struct should also be placed. What it means? Let's check it in the upcoming example. Struct employee, mention all its member, terminate it with the help of semicolon, and later on in your program, whenever required, use your structure name having list of all the objects, keeping in mind that this structure name should also have a keyword struct in its initial position. So struct employee, this is the whole line mentioned over here, struct employee, and then list of your all objects or list of all the variables in terms of comma separations. If you want to skip, don't want to use struct always in your program, so it is suggested that define a type def of type def struct employee and do it normally, and this type def will give you a liberty that at the time of mentioning variables of it or creating objects of it, no need to give a struct keyword initially with the name of your structure. That means tag name directly and then the all variables of it. See, note when the type def is used, then at the time of declaring the variable of a structure, you do not have to use keyword struct before the tag name. Now giving values to members. In structure, individual members are not independent variables. This is a core element of any structure. Please remember it always. In a structure, individual members are not independent variables. So they are linked with the tag name using dot operator, which is also called a member operator. So its syntax will be variable name dot member operator. In this way, I can call individual member of my tag. Dot operator has the highest priority over the unary operators. See example, struct student having all its member as roll number, name, age and marks. The tag name is a student. Now later on I am creating all my variables of it. Struct tag name student, S1, S2, S3, three such objects or variables, and now I want to access an internal members of this S1. So what I have to do? I have to call them in association of this particular way, variable name dot member name. The variable is S1 dot roll number, S1 dot name, S1 dot age, S1 dot marks. Now if I want to assign some values to it, I have to follow these two criteria. Values to members can be given in two ways, using assignment statement or by taking input from keyboard directly from the user. This is actually an initialization part of a structure. So structure initialization, like any other data type, a structure variable can be initialized. The two ways of initializations are individual member initialization and array-like initialization. If I call individual member initialization, then again first way is using assignment statement and another taking input from keyboard, that is from the user. Let's have a deeper look into it. So individual member initialization can be done in two ways, using assignment and then taking input from user. This is from the first one, using assignment statement, I have a structure whose tag name is student, having 4 such members: roll number, name, age and marks, all of their relative data types, and this structure has been terminated over here. Later in my program, I am creating an object of it, say S1, struct student S1, and then I want to assign individual values to it using assignment statement. S1 dot roll number is 1001. strcpy string copy S1 dot name by J. S1 dot age equals to 21. S1 dot marks as 78.5. So I am mentioning this assignment statement. Equal to is your assignment operator, and with the help of this I am assigning some values to it. Now the second one, taking input from the user. The same student structure is over here, struct student, roll number, name, age and marks, and its object has been created as S1 over here. Now in spite of giving individual values in a program, I am using scanf kind of function to read it from user. Scanf ampersand S1 dot roll number C. This ampersand, this is same address operator. In terms of string, there is no need to mention address operator, so ampersand is not mentioned over here. Scanf %d ampersand address operator S1 dot age. Again ampersand, that means address of S1 dot marks. In this way I can mention individual memory elements or values to such members. Now second one, array like initialization can be done in 4 different ways. The method 1, structure must be declared as static if it is to be declared and initialized inside a function. Means static is always used when I am declaring a structure inside some function. It may be anyone including main. Say this is main. I have declared one structure inside that. Its tag name is student, and here I am using static keyword to make it global. Static struct tag name student S1 as, this is array like arrangement. This roll number is, if I mention it like that, marks are over here, age is mentioned over here, name is mentioned here, and the first one name. You can see very obvious that all such array elements are mentioned in a way where they are following their individual sequence. Say first entry is roll number of integer, so first entry is of integer type, second one is of character array, that means a string. Here second is a string, third is integer, fourth one is float, and fourth one is float. So sequence matters. Similarly, you can have n number of such variable declarations. Say this is S1, similarly S2, and similarly S3. And in this way, you can access them anywhere in your program. Second one, along with the declaration. So I am mentioning my structure, static struct student. In this way, static is optional. Integer roll number, name, age and marks, and see, just before terminating it with the semicolon, I am mentioning all my such blocks, S1, similarly S2, and similarly S3, and finally it has been closed with the help of semicolon. So in this way you can initialize individual objects with its member values at the time when you are declaring your structure. That means along with the declaration. The third one, when structure is outside the main, then by using struct keyword and tag name. Now I am mentioning my structure outside the main. Struct student having all such members, they has been closed and main starts over here. Inside main you do all your demanded works and then you want to initialize it, then call struct student s1 array elements all the values, similarly struct student s2 all such values, struct student s3 within braces all such values. Keep in mind that sequence matters. Sequence matters. If I use 1001, then 21, then J, and then 7.78.5, this will not be initialized because I am violating the sequence mentioned as string then integer, but I am trying to do integer then string, so it will not be allowed. Sequence should be same as this has been mentioned over here. The fourth one, without the tag name. Without the tag name. Void main static struct C. No name is over here. No tag name is given over here. Roll number, name, age and marks. So whenever this kind of arrangement is required, it is mandatory for me just before terminating my structure, I have to mention all my objects before terminating it, and those objects must have their individual array like assignment. All these values belongs to S1, all 1002 Ajay 20 70.5 belongs to S2, and similarly 1003 Vijay 21 and 80, this belongs to S3. So these are the four different ways how you can handle the initialization part of your structure elements. Now, whatever we have studied in all previous slides, those has been summed up in four different rules. The first one, you cannot initialize individual member inside declaration template. Second one, initialization sequence should match the declaration sequence. This is what I am telling you in the previous slide. The sequence matters. It has to be mentioned in the same way as it was declared in the structure. Rule 3, partial initialization is valid. Okay, what it means? If I check individual earlier example, there was roll number, there was name, there was age, and then marks. If I mention it as, this is my declaration and I am mentioning at S1 equals to 1001, that's it. What will happen? What will happen? All the other values, name, age and marks, this is your partial. Partial initialization. Partial initialization, then what will happen? This is valid. What happens to all name, age and marks? See, the uninitialized members will be assigned to default values. What are the default values? 0 for numeric members and null for character members. So if I am mentioning S1 equals to 1001, then S1 dot name will be null, S1 dot age will be 0 and S1 dot marks will also be 0.0. So in this way, partial initialization is allowed and the rest will be initialized either 0 or null. Now have a simple, very simple example of structure as a whole in one single program. Read it, create it, read it and then print it. So write a program to read and print the details of student structure. Hash include stdio.io.h, you know it very well. Then declare a structure having tag name student, struct student, integer roll number, character name of 50, integer age, float marks, terminated, and later create a main, have an object of it having tag name is student. So struct tag name object struct student s1, print enter student details. Now read all such details with the help of scanf. Scanf ampersand s1 dot roll number, scanf percent s1 dot name, scanf percent d ampersand s1 dot age, scanf percent f ampersand s1 dot marks, and do all other jobs. Later on, whenever required, use printf statements to have a print of such values. Printf student roll number, percent d s1 dot roll number, student name, percent, this should be s, this should be s1 dot name, age, percent d s1 dot age, and student marks, this should be f, and ampersand s1 dot marks. In this simple way, you can do all such structure based programs very easily. So here we ends our first lecture, Introduction to Structures in C Programming. This is the end of your part 1, and in next lecture we will compare two different structures, different ways to mention structures, nesting of structures, memory management of structures, kind of things. Thank you.